Hi folks, Mr. Long here. This is type 2 of the chain rule where we have we're combining algebraic functions and values of functions from tables. In type 1, the inside function was the general function like f of x, g of x. This time, though, you're going to see the inside function is actually a regular algebraic function, and the outside function is the general function, okay? So when I say general function, I mean f of x, g of x, and we figure out what the values of f of x, g of x, f prime of x, and g prime of x are from a table of values. Okay, so here's our first function right here, and I'll should highlight that. So there's our first function. And we want to get, this seems weird, but we want to get the derivative when x is the fifth root of 7. You're going to see how this is connected. Think about that. X to the fifth, and there's your x value. What is the fifth root of 7 to the exponent of 5? Doesn't putting an exponent on a root undo it? Like root of x squared is just x, right? That undoes it. So you're going to see why that comes into play later. So it's pretty clear that our inside function is the x to the fifth, right? There's your inside function there. That's your inside function. And your outside function is 3f. So let's take a look at this and go through it. So first things first. Down there, sorry. So x to the fifth is the inside function. That's u. U is always the inside function. The derivative of that is 5x to the fourth. Then what we do is we look at our outside function. Again, what is outside of x to the fifth? Well, 3 and f, right? So 3f at u, because we're replacing x to the fifth with u. So that's the y value. Now I need to do the derivative. Well, what's the derivative of f of u? F prime of u. That's all it is, right? It's just f prime at u. So now, as I'm doing the chain rule, I need to multiply this and this together. Okay, so how do I multiply those together? I've got coefficients here of 5, or coefficient here of 5, and a coefficient here of 3. 5 times 3 is 15. And then I've got x to the fourth and f prime of u. Okay, and that's going to give me the general derivative, y prime. 15x to the fourth and f prime at x to the fifth. Why is that x to the fifth? Because that's what u is worth. Okay, u is worth x to the fifth. So now what I need to do is substitute, this is the general derivative, right? Now I need to get the tangent slope at the fifth root of 7 is the x value. And I know that seems weird. So the 15, we still have the 15. Now I've got the fifth root of 7 all to the exponent of 4. Now that's a pretty, you won't be getting an exact value of that, like a decimal approximation of that. We can, but it's not something we certainly know in our heads. Then I need to do f prime at x to the fifth. Well, what I need to do, if you notice, this part is pretty important, so I'll highlight it. I need to get the derivative for the fifth root of 7 all raised to the fifth. Well, that just cancels out the 5's. The root and the exponent cancel each other out. So all I'm left with, 15, and then notice I put it into a rational exponent. 4 is the exponent, 5 is the root, so that becomes 7 to the 4 over 5. And then it just becomes f prime at 7, right? We knew there was a reason why we had such a weird x value for where we wanted to get the tangent slope. So it just becomes f prime at 7. And is f prime at 7 on your table? For sure it is. X equals 7 is on your table. So now you can do that. Now we just go through, same thing, and now take a look at your table, go to x equals 7, go down until you hit f prime, and you're going to notice that it's a value of 1. Okay, so I multiply this together. Now the exact value is this right here. That's the exact value, 15 times 7 to the 4 fifths. Then notice we've got an approximate sign here. So we can approximately get the answer as 71.1. Okay, but this is also, this answer right here is fine. So that's your exact value answer there. And this is your approximation answer here. Okay, so let's go on to our example 2. So this time, the function that we're looking at is g of 1 over x squared. So the inside function is 1 over x squared. The outside function is g. And I want to get the derivative when x equals 1/3. Now I want you to think about what numbers are on your chart again for x. You have numbers of 1, 3, 5, 7, and 9, right? 1, 3, 5, 7, and 9. You don't have 1/3. But somehow that 1/3 through the mathematics over here at 1 over x squared is going to turn into one of those x values, right? Because the only x values that you can get slopes at and y values at are 1, 3, 5, and 7. And 9. 1, 3, 5, 7, and 9. Anyway, let's go through this. So 1 over x squared I can write as x to the negative 2. So that is the inside function, x to the negative 2. What's the derivative of x to the negative 2? Bring the negative 2 out front. X, and then I reduce the exponent by 1 becomes negative 3. Now, how am I going to write that? Negative 2 divided by x cubed. Right? That's a nicer way to write that. Now I need to do, and that's the inside derivative, the outside derivative. Well, what is the outside function? It's just g at u, because I changed 1 over x squared into u. What's the derivative of g of u? G prime of u. That's it. Now I need to multiply these together. So I've got to multiply that and that together. So it's just going to be negative 2 g prime at u divided by x cubed. Now again, what's u worth? 1 over x squared. So the first thing we do is write out the general formula. Negative 2 g prime 1 over x squared. And then I have to write that as over x cubed, right? Because it's negative 2 times by g prime of u, all divided by that x cubed. I think I said x squared last time, all divided by x cubed. Okay, and again, the 1 over x squared is what u is worth. Okay, now let's substitute. So notice the pattern's the same every time. I get the general derivative first, then I substitute in the known x value. So I have to look for g prime of 1 divided by x squared. But what's x worth? 1/3 squared. So I have 1, I'll highlight that right here. I've got 1 divided by 1/3 squared. I don't know if you remember, but 1/3 should be cubed. That should be a cube there. I'm not sure. I thought that was a cube, but anyway. Oh no, it's not. It's squared. Hey, that's squared there. Sorry, folks. 1/3 squared inside. So what's 1 divided by, oh, I know that goes down to there. What's 1 divided by 1/3 squared? So first of all, what's 1/3 squared? It's 1 squared over 3 squared. That's 1/9. What's 1 divided by 1/9? Well, 1/9 goes into 1 9 times. The bottom is 1/3 cubed, and that's up here. So what I've got there is 1 divided by 1/3, because that's in the bottom, right? So this 1 just represents all this stuff here. So 1 divided by 1/3 cubed is the same thing as 3 cubed, because we would do the reciprocal and multiply. It'd be 3 over 1 cubed. 3 cubed is 27. So let's start going through this. So what I would end up with is negative 2 here, multiplied by what that is worth. That's worth 27. So negative 2 times 27 is negative 54. And then this thing here just becomes g prime at 9. Okay, that becomes g prime at 9, because 1 divided by 1/3 squared is 9. So now I go to my table. I go to x equals 9, and then I go down until I get to g prime. Negative 54 multiplied by 7 is negative 378. So the slope of the function y equals g of 1 over x squared at x equals 1/3 is negative 378. That's a very steep negative slope. So again, I know these are tricky, but follow the principles of the chain rule. The inside prime, the outside prime, multiply them together and work through the process. Okay, folks? So these are important questions that will definitely put you ahead in terms of getting you ready for any exam and your calculus if you have to take it next year. Have a great day.